In this video, we will show you how to configure per user tunneled node on Aruba Switch. We will also configure local and downloadable user roles, as user roles are vital to the per user tunneled node feature. We will configure policy in Clearpass to push a user role VSA to work with local user roles, as well as configuring Clearpass to use downloadable user roles. We will finally then, as part of downloadable user roles, configure certificates on the switch to make a secure, trusted connection between Clearpass and the switch to download the user role. We will show a way to do it with Windows Server as well as CentOS Linux. So before we get started into the configuration of per user tunnel node, I kind of want to go over how it works, what we're going to talk about, what's going on behind the scenes here, so the audience will have a better understanding when watching this video. So the idea of tunneling these user clients comes off of a feature that we released in 1602 called per port tunneled node. They work similar, per user and per port tunneled node, except with per port tunneled node, what you would have here to your controller, one, it only worked with a single controller. Per user tunnel node works with a controller cluster. And the idea with per port tunnel node is that you would choose a port on a switch, and it's a very static setting, so everything on that port is tunneled back to the controller. And then the controller would control all the policy and authentication at the controller side. Now, per user tunnel node, we're actually authenticating users at the switch, so the authentication is brought down to the switch. And so what we do is we turn on authentication on the ports, and users now can come online with their laptops or with their IoT devices, and when these devices are authenticated at the switch, that checks with Clearpass in our case, and in Clearpass there's policy set, so if the user authenticates with the correct policy, it is passed a VSA or vendor specific attribute which contains what user role, in the case of local user roles, that the user will be placed on. So Aruba has a concept of user roles that based on a user and what role they have in the network, they are assigned certain policy within the network. So maybe an employee would access certain parts of the network, or a contractor would only have more limited access than an employee. Different IoT devices can have user roles as well. So you can use MAC authentication on the switch to authenticate via MAC address the device, whether it's a security camera, a card reader, a printer, any kind of device with a MAC address that can connect to the network, that can be also given certain policy based on the user role. So now with the idea of per user tunnel node, we have specific users can download specific roles that apply to them specifically and specific devices, and then they will be assigned specific policy that has been pre-designated within Clearpass or on the controller. So most of the policy will set on the controller, since there's going to be, as we see in the configuration later on, there's a primary role and a secondary role. The primary role is the user role that will exist on the switch if you're using a local user role. Now, we also introduced a feature called downloadable user roles, where that exact same syntax that you would have on the switch will be in a Clearpass policy and passed via a VSA called HPE CPPM role. And then you just set the switch to download the role, any role within the network. So now so instead of creating thousands of local user roles across a large network on all these different switches, now we can just create all the user roles within Clearpass and have the switch download them dynamically. So that's kind of the difference between local user roles and downloadable user roles. Local user roles will be predefined on the switch, and then downloadable user roles will be configured in Clearpass, and this switch needs to be configured to download that from Clearpass. So I'm going to show both steps, local user roles and downloadable user roles. So in downloadable user roles, there's an extra step with certificates. Now there's a couple of ways that I've tested to be able to install the certificate on the switch to make a secure HTTPS connection with Clearpass to download the user role. One way is to do it through a Linux VM using OpenSSL. Another way is if you have a Windows Server running, you can sign the certificate using Windows Server. So I'm going to show both of those ways in the video. Now, user roles are just a small portion of per user tunnel node. The idea is that we can centralize all our network policy in the controller and just tunnel all wired traffic back to a controller, similar to kind of how a wired AP, if a wired switch was an AP, it would act like an AP access point or AP does in the wireless world. On an Aruba AP with a controller, everything is tunneled back to the controller, and then all policy is handled at the controller. Now we can do the same with wired traffic. All wired traffic will be tunneled back to the controller, and now we have wired and wireless policy all being handled by the controller, and then being able to uh, provide the role-based access at the controller level in connection with Clearpass. So that's what I'm going to show today is how to configure per user tunnel node local and downloadable user roles with this video. To start out configuring per user tunnel node, we need to configure the switch to authenticate. So first we'll need to authenticate it to a Radius server, and we'll need to configure the Radius server settings. So here we're configuring the Radius server host, which is the Clearpass instance. So we'll need to add in the IP address to the Radius server, as well as turn on dynamic authentication and set up a time window for the connection. The time window is the amount of time that the dynamic authorization stays current. So setting it to 0 here means there is no time limit. So then we enter in the Radius server key, and we should be configured here to start configuring our port access. So here we're setting up port access to use 802.1x on a port 1/48. So we use that using the AAA authentication port dash access. First we need to enable EAP radius, and then we configure it to use 802.1x on the port 1/48, since this is a two-member 3810 stack. Then we turn it on the port access authenticator to active, save the configuration, check the configuration. So after we validate the configuration, then we can start configuring the tunnel node functionality. So first we're going to add the controller IP which the tunnels will be tunneled to. So this, in our case, this is a standalone, but in a cluster you would use the master IP. You also turn on the mode as role-based as opposed to port-based, since we're using per user tunnel node. Then we'll start configuring the local user role. So first off, we're going to demo how to use local user roles with this. So we're creating a local user role called test role, and then applying VLAN ID 15. So the users in this user role will go to VLAN ID, and then we enable it. One thing we forgot to do there was add in the tunnel node command. This is the command that does all the magic. So that is the tunnel node, tunnel-node-server-redirect, and then it goes to a secondary role, which is the user role on the controller. So for this purpose, we're just going to use the default authenticated role on the controller, but you can use anything and apply policy to that. So then we'll validate it in the configuration and make sure it's configured appropriately. And we can see up there that we have the appropriate commands in there. So the next step is to configure Clearpass to pass along a VSA which contains the user role name that we configured on the switch if you're using local user roles. So first we created a 802.1x service, and then in that service we'll need to create a policy. So in this service we're just using Ethernet and local users, and then we're going to use the local user repository to authenticate our users on. And then in enforcement, we'll create a policy for this. So we have a policy here, and in that policy it contains a profile. And so within the profile we have a rule where the user, when it authenticates, will have a role in Clearpass. And once it authenticates that role, it'll pass this VSA here, which is HPE user role and test role. So then once these rules match, it will pass that VSA or that user role back down to the switch after the user authenticates. It's important to make sure we have the updated HPE dictionary, so we can do that under Dictionaries Radius. You can download the new dictionary from the Aruba Networks support site. So then in our configuration in Clearpass, we'll need to create the local user. In this one, it's called dirtest with a role of an employee. And so once that user logs in from the client, Clearpass will apply the profile to it and then pass the user role down to the switch. We also need to make sure we have our device authenticated by Clearpass to um, access and force policy at the ports. So here we have to add basically we have to add our switch into Clearpass. So we'll add our 3810 here, and then for the radius shared secret, we'll make sure that matches the key that we configured on the switch. And then once that's done, we'll be able to authenticate users at the switch into Clearpass. So really the only thing when you're using local user roles and per user tunnel node, the only thing Clearpass is doing, acting as a radius server and passing along this VSA. And then once the switch sees that VSA and that the users um, applied to the network and access the network, then it will start tunneling back to the controller. So we can verify that by running the command show port access clients. And we can see that the user here got a user role and the MAC address and which port it's on and what VLAN. We can see the show tunnel nodes or state command. We can see that the management tunnel has been formed to the controller at 10.5.8.6. And then once the users come on, we'll start forming user tunnels as well, so which can be to different members of a cluster. In this case, we're running a standalone controller, so it's on both. Now this is with the show tunnel node over server information command. This is the bucket list. So this is kind of the hashing algorithm that different users can go to different controllers within a cluster. And so we can also look at statistics with the tunnels and for troubleshooting and make sure the heartbeats are increasing both on the transmit and receive, so we can confirm that the tunnel is working appropriately. So we can see that the numbers are increasing. So that looks good there. Then we can verify users using the show tunneled node user all command. And we can see the users tunneled. So we see here we have the user, the MAC address of the laptop we're using, port 1/48, and it's using the secondary role authenticated. Now if we go to the controller, we can also check the commands here by using the show tunnel node dash manager command, tunnel dash users. And we can see the user listed here. We can see the tunneled user MAC, which is the laptop MAC, the tunneled node MAC, which is the switch MAC. We can verify that with show system on the switch and see the MAC address there that they match. See which VLAN, which controller IP, the GRE key, tunnel index, and any flags associated with that. We can also run show tunneled node dash manager user tunnel table. Gives us a little bit of frame information. So that was how to configure per user tunnels using local user roles. Now we're going to move on to downloadable user roles. And first we need to configure Clearpass for certificates to use downloadable user roles. So in Clearpass, we'll go to Administration, Server Certificate. We'll change the server to HTTPS. Then we're going to create a certificate signing request. And once this window, the wizard pops open with a window, we'll add in our organization, organizational unit, location, state, country. We'll need to give it a private key password and verify it. We'll click submit, and that'll generate the signing request. So we'll also download the signing request and private key files, and then we're going to copy and paste what's in the window. We'll then go to our Windows server and open up a web browser. Then we're going to navigate to localhost /certserv, CERTSRV. Once we get there to the page, we're going to click on request a certificate and then advanced certificate request and then submit a certificate using a PKCS. We're going to copy and paste the signing request, and then we're going to select a web server for the certificate template, and then click next, submit, and click yes. And we're going to download certificate chain. We're going to make sure it's base64 encoded, and then download certificate chain, and then open the file that it downloads. Then we'll see the two certificates, the root cert and the server cert that we created here as we expand the files. Then we're going to export both these files. So first we're going to export the server cert using the export wizard. Go to base64 encoded. And click next on that. Then we'll put it in the location. I think I'm calling it server cert for this. And submit, and it'll export. And click next. Finish. And it'll export successfully. Then we'll do the same for the root certificate. Click on base64. Save it as a file name call it root cert. Export. It'll finish successfully. So now we need to copy the root certificate into the trust list on Clearpass as well as onto the switch itself. So we're going to copy the files here, or make sure we know where the files are at. I'm RDPing, so I'm going to copy the files over into my VM that I have Clearpass running on. So I'm going to copy both those files over here. Looks like I've done it before, so I'm going to replace them. So now that I have the files copy, and make sure my TFTP server is pointing to the directory, so I can copy the root cert onto the switch. So now from Clearpass, we can import the server cert. Well, first we need to add it to the trust list. So we go to the trust list, we go to add, and then we point to the location of the root certificate file. And we can add that into the trust list. Then we go back to server certificates, and then we import server certificate, make sure we're on HTTPS. We choose the server cert file that we created earlier, and then we use the private key file that we originally created from Clearpass. Should be in the default downloads by default. And then we'll add in the key that we created earlier. Then we'll import it. So once it says we imported successfully, make sure the root certificate matches up. We got to log back into Clearpass after we do this. And then once we log back into Clearpass, we can check the trust list for our certificate. We look through the list and we can match it up to the root certificate values. We'll check the server certificate in the HTTPS, make sure the dates are correct, and then make sure the root certificate's correct. And then we can go to the switch and copy the root certificate over. We got to check the time first though. That's an important step. Make sure your time matches on your switch and your Clearpass. So we can see what certificate trusted anchor profiles are installed. So it looks like we have something on here already in show crypto PKI TA-profile. So we can clean that out using crypto PKI zeroize. And then that wipes out all certificates. And then we create a new profile using crypto PKI TA profile. We'll call this PUTN-demo. And then we'll copy using TFTP, TA certificate, the profile that we just created, and then the IP address of our TFTP server. Make sure the location is correct too, where the root certificate's installed. And then we'll copy that over to our switch. Make sure we have the correct file name at the end there, that it matches what's in our TFTP server. Using this, we can copy the name directly from the TFTP server. So the transfer is successful. We can verify that using the show crypto PKI TA profile command. And we can verify that the certificate installed correctly. So after we get the certificate installed, the next step is that we need to create a identity account for Clearpass. So this we use the Radius server CPPM identity. We're going to call the user demo test. So basically this will be a read-only administrator that we create in Clearpass. So here we'll give it the username and the key, save it to the switch, then we'll go into Clearpass to admin users, add the user, and create the ID that we just created on the switch. I want to make sure it's case sensitive and we have the correct password verified, and then we add that user. Make sure it's a read-only administrator. So then once we're done creating the administrator, we can go back into the switch and bounce the port. So here we're going to disable and re-enable the port and look at the access, and we see that the user role is downloaded. We can see under user role that with an asterisk, if it has an asterisk in front of it, it means that it's a downloaded user role. We can use show user role downloaded to see the name and list of them. We can do detailed to see any detailed information within it. And as we did with local user roles and per user tunnel node, we can do the show tunnel node user all command and see that the user role's up with the authenticated secondary user role, the MAC address, and then which port it's on. That's how we configure downloadable user roles in Windows using a Windows certificate. Now we're going to use Linux. For the purpose of this demo, we're running a CentOS 7 virtual machine. We're opening up the terminal here, and we're going to navigate to the etc/PKI/TLS/MISC directory. From there, that's the default directory to do all the certificate files. We can verify that with pwd, and then you can check the OpenSSL version, make sure it's a fairly current version. So we're going to run a series of commands to set up the certificate database. We're going to create the serial file here using the touch command, and then we'll change permissions on the serial file. Change it to 777 for all rights. We're going to create the CAcert, or the certificate file itself, cacert.pem. We'll set the permissions on that. Then we'll create the private key file, put it in the private folder. So we'll create the private folder and call the key cakey.pem. And we'll set the permissions on that. Then once we're done with that, we'll create the index.txt file. The index and the serial files are both flat files used to keep track of signed certificates in OpenSSL. So we'll create the index and change permissions on the index. And then we'll give the serial file 1000 line entries using the echo command. And then we'll set the permissions, or change the permissions on the index serial and OpenSSL.cnf file, which has all the OpenSSL settings in it. And we'll set that to 600. Once we've set all the file permissions, we can create the new cert. And we use that using the -new cert command. That generates a new private key, and then we need to enter in the passphrase that we want to use and verify it. And Then set in all the organization information that similar to what we did in the certificate signing request in Clearpass. We can put a new host name or leave it blank, or use the same one that we used in Clearpass. Once we've done that, we're going to copy the new cert and the new key that we created into the CA cert and CA key that we created when we were setting up OpenSSL. So we'll do that, of course, using the copy or CP command. We'll copy that into the directory where CA cert and CA key reside. And then we'll open up the new key or the new certificate that we just created using a text editor. You can use VI. I prefer gedit. So we'll open up the cacert.pem and we'll copy the certificate that we created. And then we'll create a new file. I'm going to call it root cert to keep it consistent with what we were doing before. I'm going to create a new text file and copy that certificate into it and save it as rootcert.pem. So we'll now move back to Clearpass and we'll go back into the server certificate folder under administration, and then we'll create and generate a new certificate signing request again. Make sure we're on the HTTPS server certificate. Same as before, we'll enter in all our organization and location information. We'll enter in our private key password, make sure both are the same, and submit it. That'll generate the request, and then we can download the files, of course. And running Firefox here in CentOS, and maybe it's because I'm going through XRDP, but the external windows don't show up very well. But both files download to the default downloads folder, and then we'll copy the certificate signing request file over to the etc pki tls mis folder, the default OpenSSL folder. So then once we find our files, we can copy them over to the OpenSSL folder. Go down into the root directory, the etc pki tls miscellaneous folder. Then we can close out gedit and then check the directory, make sure the new certificates that we copied over correctly. And then we can run this command that will sign the certificate signing request that we created from Clearpass. Be mindful of the days that you set, because that's how long the certificate will be good for until it expires. So we'll sign it against the root cert that we created earlier, and then the private key, of course, that we created earlier. Then we'll output it to the same directory. We're going to call it servercert.pem. We need to make sure we enter our sudo password and then our private key that we created earlier. So after we've created all the certificate, the signed certificate, server certificate, we can go back to Clearpass and install that into Clearpass. So we'll come back here to Clearpass, go to the trust list, we'll make sure the root certificate's installed that we created earlier. If not, we'll go ahead and create it. Not seeing it here, so we'll add it. Click on add, and then we'll browse to the root certificate file in the OpenSSL directory. Then once we find the file, select it, add the certificate, then verify that it installed correctly. Go back to server certificate. We need to make sure we're in the HTTPS server menu. And then we'll import the server certificate that we created in OpenSSL. And then we'll import the private key file that we generated originally when we did the certificate signing request. Make sure we have the correct private key, and then import it. Then we see that the certificate has installed. So once we've configured the certificates into Clearpass and verified them, we can go back to the switch and then re-authenticate the client and check the list of client authentications, and we see that it's downloaded a user role. And that is how you configure downloadable user roles with certificates from CentOS. Thank you for watching. I hope this demo was beneficial and helps you configure per user tunnel node on your switches.